My name is Tan, and today we'll be discussing the basic principles of conversion between radians and degrees. It's fairly simple, so without further ado, let's get started. A full circle is 360 degrees all the way around, and in terms of radians, this is 2 pi. If you were to start from anywhere in the circle and go halfway around, that's where pi lies, which is 180 degrees. If you were to finish the circle and return to the original position at 0, this is now 2 pi after having gone around the full circle, and that's also 360 degrees, the entire thing. And if we were to convert from degrees to radians and vice versa from radians to degrees, we need to find both of their conversion factors. To do that, we have to reduce each of their values to their unit value, which is their minimum value, also known as 1. For degrees, that would be 1 degree. For radians, that would be 1 rad. So in order to reduce 180 degrees into 1 degree, all we have to do is divide both sides by 180 degrees. This leaves us with 1 degree on this side and on the other side, pi over 180 degrees. Therefore, the conversion factor for degrees is pi over 180 degrees. To find the conversion factor for radians, it's the same thing. Except all we have to do is, instead of dividing both sides by 180 as we did before, we'll be dividing both sides by pi, because that will change pi into 1 rad, which is what we need. Look to the other side, and we're left with 180 degrees over pi. Which is our conversion factor for radians. With these two conversion factors, we can basically convert between any set of degrees and radians. Let's start off with a fairly simple example to show this method. 60 degrees. So our problem is a degree, and we're trying to go from degree to radians. And since we're starting off with degrees, we have to use this conversion factor. The reason being is because the degree value is on the bottom in the denominator for this conversion factor, whereas it's in the numerator for the problem. The fact that they're on opposite levels makes it so that we can cancel out the degrees, and so we're left with the radians, which is what we're looking for. Therefore, when given degrees, we will use this conversion factor. If we multiply by that conversion factor, pi over 180 degrees, as expected, the degrees will cancel, and all that's left to do is multiply across, getting 60 pi over 180. All that's left is to reduce, simple division, and that gets us 6 over 18, which is 1/3, leaving us pi on the numerator and 3 on the denominator. Pi over 3 is our answer in radians for 60 degrees. To do a simple check, all we have to do is change pi into 180 degrees, and divide by 3 to see if we get 60 degrees as we had initially. And surely we get 60 degrees. That checks off, meaning pi over 3 is our correct answer. Now we can try the conversion method to go from radians to degrees as well. So to do that, let's try the example pi over 15. Now, when we're given degrees to start off with, and we have to find radians, we use, as I said before, this conversion factor. But when we're given radians at the beginning and we're to find the degrees, translation or conversion, we have to use this conversion factor. That's because in the problem, pi is in the numerator, whereas in the conversion factor, pi is in the denominator. When we multiply these two, the pi's will cancel, so the radians will disappear and we're left with degrees, which is what we're looking for. We multiply as we did before, but instead using this conversion factor, 180 degrees over pi. The pi's cancel as expected, and we're left with 180 degrees over 15. All that's left is to reduce this into 12 degrees. Our answer. Now, there is a small shortcut to solving for 8 degrees conversion from radians, but this only applies to if we were given radians to start off with, and it's recommended to be used, the shortcut, if it's a rather complicated problem as compared to before. So what I'm meaning by complicated is, let's say instead of just pi over a number, it's 5 pi in the numerator and 12 in the denominator. So it may look a little overwhelming, but it's the same process, and I'll show you a quick shortcut. So it's the same as before. We're technically using this conversion factor, but instead of writing this entire factor out and multiplying, we are just going to change pi into 180 degrees. Because even if we were to multiply by the conversion factor, 180 over pi, we would still end up crossing out the radians, and we'll be left with 180 in replacement of pi. So instead of going through all that multiplication, all we'll do is change pi into 180 degrees. This becomes pi 5 times 180 divided by 12. So it's a quick one-step problem versus having to cancel and everything. And this, after reduction, gets us 75 degrees. It's recommended that instead of solving for the numerator first, that you separate 180 over 12 for easier division, and then later on you take the quotient and you multiply it with 5 to get the answer. 75 degrees is the answer, and that is the quick shortcut for if you're given radians as the problem and you're looking for degrees. But otherwise, it's recommended to use the conversion factors so that you have a more clear understanding and you can now convert between degrees and radians and vice versa. Thank you.